Okay, so now what we're going to take a look at here is how to calculate or calculating a inverse. Okay, so here, what we want to think of here is when we're solving to find a inverse, right, we really are looking at this product, right, IN. And the way we want to think of this here is we're thinking of solving n systems here simultaneously, right? Where we hear this product here, one for each column of B, right? We know what it has to equal to, okay? So all of them have the same coefficient matrix, all right? And we think of each column and we get the equal to I to the m. So what we want to do here is we want to create a larger matrix where we want to essentially kind of put together, augment A not by a column vector, but by the whole identity matrix. All right, and the goal here is that we reduce row echelon form. So if we reduce row echelon form, what happens is we'll get the identity on the left side here, right? And what will be left on the right side would be the A inverse, right? So that is the goal here, to find a matrix, right? That we do this operation here, right? So let's work through an example here. So here, now if we are along the way unable to do that, right, then that means that the matrix, as long as all our calculations were correct, our matrix is invertible. All right, excuse me, our matrix is not invertible, so we will not be able to find a matrix that is the inverse for A. Okay, so let's start here with matrix 1, 1, 1, 1, 1, 2, and then 2, 1, 1. All right, and I want to find A inverse. Right, so we'll start off here. We'll do our augmented matrix. Right, in this case here, we'll have 1, 1, 1, 1, 1, 2, 2, 1, 1. Right, and I'm going to augment it here on the other side with I3. Okay, so now we have this big 3 by 6 matrix here. And I'm going to start by, again, I want to get the identity or reduce row echelon here on the 3 by 3 on the left. So I'll start with my first pivot up here, this 1, and then zero out everything below that. Right, so I'll do that by taking negative R1 plus R2, and that'll be my new R2. And I'll also do negative 2R1 plus R3, and that would be my new R3. Okay, so if I do that, my resulting matrix, the top row remains unchanged. And then my second row turns into 0, 0, 1, negative 1, 1, 0. And then my third row becomes 0, minus 1, minus 1, negative 2, 0, 1. Okay, now what I like to do next here, since if I look at that second row, it looks like I have the last row of my reduced row echelon form, right? So just to kind of simplify my calculations, not have to double back and add a negative 1 back into that middle term, I think the most straightforward thing to do here for myself would be to just swap out row 2 and row 3. Right, so I'm going to change those around, and that's going to leave me in a much better position here, I think. So my second row is now okay. And we see here now I'm done at the third row, right? I've achieved what I wanted there, right? Just a pivot in that third position there in the last row. Okay, so now once I'm here, now let me take this pivot here and then from here, work my way back up to zero out the rest of the top column there. All right, so I'll do that by doing R2 plus R3, and that'll be my new R3, our new R2. And then also negative, where am I at here? All right, negative R3 plus R1, and that's going to be my new R1. Okay. Okay, so in doing that, we zero out everything in that third column above the 1. So we get 1, 1, 0, 2, negative 1, 0, 0, negative 1, 0, negative 3, 1, 1, and then the third one here, 0, 0, 1, negative 1, 1, 0. Okay. All right. So now we're much closer here. The last thing I want to do here is I want to zero out. So now I'll go to that second row and zero out the 1 above it, right? So I'll just add R2 plus R1, and that'll be my new R1. Okay, so that means we'll get 1, 0, 0, negative 1, 0, 1, and then down here we got 0, minus 1, 0, 0, 0, 1, and then negative 3, 1, 0, excuse me, negative 3, 1, 1. And down here, negative 1, 1, 0. Okay, and one last step here, right? We don't quite have reduced row echelon form. The last step would be to do negative 1, R2. And now that gives us our desired result. Here, and we get negative 1, 0, 1, negative 3, 1, 1. All right, and here we go. Right, so now what we have here, again, this is our identity matrix, but more importantly here, that is our inverse. Right, so A inverse is negative 1, 0, 1, negative 3, 1, 1, 1, 0. Right, and what we can show here, right, is that A inverse times A is equal to A times A inverse, which is equal to I3. All right, so that, and not only that, what we can show here is that this actually now for any vector chosen for B, if I choose my coefficient matrix, I can find a solution to the system, right? And rather easily now, right? Because now what I'm saying here from like our previous video, that X is A inverse times B, right? So for any choice of B, I can just multiply it by the matrix A inverse and find the solution, right? So I did this, I put in a lot of effort to find the inverse, and now I'm able to solve this a wide variety of systems of equations here just by doing this quick matrix vector product here. Right, so now we can see the power of knowing the inverse of a matrix. Okay? All right.